Hi, in this video we are going to discuss one of the statistical approach case test to find the distribution of the data. In previous videos we are discussed one of the another approach, that is a QQ plot. It's a basically graphical approach to find the distribution of the given data. But sometimes we need a value. At the time the graphical approach is not useful much. At the time we are going to use the case test. For this, let's consider an example to get more things. Let's x1 and x2 are the two random variables. We have to find these two random variables are same distribution or not. Like in the QQ plot also, x1 and x2 are the same two random variables. We have to find these two random variables are same distribution or not. Like in the QQ plot, we have to consider a target and another is the actual that we already know. Let us consider x2 is the target distribution that we don't know. And x1 is we actually know, known distribution. Like in the QQ plot, we are going to say that these two distributions are same or not by using the another one. Let's go some deep dive into this one. Let us consider x1 contain n number of points. x1 contain n number of points, and the distribution we know. Let's consider Gaussian distribution. And x2 contain m number of points. We don't know the distribution. To find this distribution, we are going to use case test. Initially, we are going to find the CDF functions to the two random variables x1, x2. Now let's plot those things. For suppose the CDF functions to the x1 random variable is x1 and this one is like that, and for x2 it was like this. Here we are going to find the supreme distance between these two CDF functions. What is the supreme distance? Means the maximum distance possible between these two CDF functions at particular value. For suppose this might be a maximum distance possible at some value at x equal to, let's take this one as x. Now the distance we can the distance that we are found at point x we call as calculated value, that is decalculated is equal to the supreme distance at x. X might be any value between these two range, but its value will be same for the x1 and x2 at the point f1 comma m of x minus f1n x, because okay. Now this is the calculated value. Now we are going to find the d critical value. D critical value is equal to the C alpha m plus n by m into n. We already know the m and n is the number of points we consider in the x1 and x2. And C alpha. Here the more number of points we are going to consider, the d critical is going to be low, and C alpha is equal to minus 1 by 2 log of alpha by 2. And the alpha value we will get in the problem statement. By substituting C alpha here, we are going to get the C critical. Now we have the C calculated and C critical values are there now. Let us check what will be happen, what are the values, which is if D calculated is less than D critical, then it tells these two distributions are going to be same distribution. X1 and X2 are in same distribution. If D calculated is greater than the D critical, then X1 and X2 are not in same distribution. That means here X1 we consider as a Gaussian, X2 is not be a Gaussian. Gaussian distribution. This is all the things about the case test.